This lecture is on trapezoids and kites, and as you can see here, trapezoids, the T, are a subset of quadrilaterals. However, trapezoids are not parallelograms, and we'll go through some of the properties that define them in a little while. And then within trapezoids, you have isosceles trapezoids, and I'll talk a little about what makes isosceles trapezoids special compared to just trapezoids. And then over here, we have kites, and kites and trapezoids are also exclusive to each other. You can't be both a kite and a trapezoid, and neither one of them is a parallelogram. So that's how kites and trapezoids fit into this greater family of quadrilaterals. Okay, so for just a trapezoid has exactly one pair of opposite sides parallel. So whereas parallelograms have both pairs of opposite sides parallel, trapezoids only one pair, and we call that pair the bases. So you have base 1 and base 2, and they're parallel. They don't have to be top and bottom. This can be oriented differently, but often they're just top and bottom. And then the two other sides are called the legs. And as we can see, here we have the diagonals, and they are not cutting each other in half. The diagonals for a trapezoid do not bisect each other as they would for a parallelogram. Now, because these sides are parallel, if we imagine extending this side, and extending the leg, then we can see it's two parallel lines with a transversal. And so because of that, this angle here and this angle down here are same side interiors, and so they will be supplementary. And so the bottom to the top angles are supplementary, so this angle in the bottom right would be supplementary to the angle in the top right. Now, if we want to make this an isosceles trapezoid, additional things we would add to the features we have for trapezoid is that the legs are now the same length. And because the legs are the same length, we have symmetry across the middle, and so now this little piece of the diagonal is the same as this little piece, and these two are the same as well. And so they still don't bisect each other, but now you've got isosceles triangles, top and bottom. Also, when you have an isosceles trapezoid, now the angle on the left is the same as the angle on the right, and these are the same as each other. So not only do we have supplementary top and bottom, but also from left to right they're congruent. A couple sample problems. This is just a regular trapezoid, and if this angle is 70, then we know that this angle up here is 110 degrees because they're supplementary. If this angle is 120, we know that this angle is 60 because 180 minus 120 is 60. Over here, now we're told that the legs are the same length, so now it's an isosceles trapezoid, which is going to tell us that if this is 45, we know this is 45, and so both of these are 135 because they're supplementary to the ones on the bottom. They're congruent to each other. Okay, properties of kites. Kites, a lot going on with kites. Diagonals for a kite are perpendicular. They do not bisect each other. One of them is bisected, but not both. So let's start over a little bit. So for a kite, you've got a diagonal, principal diagonal, straight down the middle here. And that pretty much separates the thing into two equal parts, left and right. So at this point, now everything is symmetric across that diagonal. So these diagonals are perpendicular. So you have right triangles. These are the same length. Because of the symmetry, these legs are the same. These legs are the same. Angle's the same as the angle. Angle the same as angle. Angle the same as angle. And so on up at these top angles as well. So this diagonal cuts everything exactly in half. The vertical diagonal, though, of course, is not split in half. Those are two different lengths. It's only the one diagonal which is split in half. And so now that we have these right triangles, we'll have situations where there'll be Pythagorean theorem. Here is a big sample problem. So this time our main diagonals come in this way. And so we've got all sorts of things we can figure out here. We're not going to use any trigonometry, so we'll assume that everything works out without trigonometry, even though these numbers aren't quite correct. So let's first get, say, this angle here. This angle here has got to be 25 degrees because this one above it's 25. This angle over here is 40 degrees because it's got to match up with the one down here. Every one of these angles around the middle is 90, so that's 90 degrees. Now, trying to find W. Okay, W squared plus 12 squared is equal to 13 squared because we have a right triangle here, and we use the Pythagorean theorem like this. We get W is equal to 5, so that's 5. Because this is 25 and this is 90, we can say that this angle is 180 minus 90 minus 25, so that's 65 degrees, which makes that 65 degrees. because this is 40 and this is 90 here, we know that this angle is going to be 50 degrees. 40 plus 50 plus 90 is 180. Again, this one here will be 50. So a couple things, last thing to figure out would be, x is 13, because that has to match up with what's on top. So you just use all this symmetry, and then y and z will be the same. And the way to get those is to say, well, let's see. We know that this is now 5 right here. And so looking at this triangle up here, we can say z squared is 7 squared plus 5 squared. So that's 49 plus 25. So z squared is equal to 74. 60 plus 14. And so therefore, z is radical 74, and also y would be radical 74. All right, that's a do's even example. Let's do ones that are a little bit easier to deal with. Okay, trying to find the numbered angles. This is a trapezoid, and it's isosceles. So if this is 62, we know that's 62 as well. This angle is supplementary to this one, so 180 minus 62 is 118 for that angle. Again, another isosceles trapezoid, so we know this will be 99 degrees, and this 2 is supplementary to 1, so that's going to be 81 degrees. All right, now some algebra involved. We want to find x. We know these legs are the same length. This doesn't really help us, so we just say 3x minus 3 is equal to x plus 5. So 2x is equal to 8, and x is equal to 4. Over here, we know the angles have to be add to 180 here and here. So we say 4x plus 6x plus 20 is 180. So 10x is equal to 160. So x is equal to 16. And once we know that x is 16, I'm going to plug it back in here. So 6 times 16 is 96, plus 20 is equal to 116. And because this is an isosceles trapezoid, we know that this angle is the same as this angle, so y is 116. Now we'll look at some kites. Because of the symmetry in the kite, we know that angles 1 and angle 2 are the same. So I'm going to call them both x for now. And in a quadrilateral, you have to, when you add the angles, you get 360. So I can say 2x plus 149 is 360. And so 2x is equal to, let's see, this will be 211, 360. And so x is equal to 105.5. Over here, we know angle 1 is a right angle because the diagonals of a kite are always perpendicular to each other. And that means this will also be 90. So now looking at this triangle, 90 and 65, subtract that from 180, and you get angle 2, which will be 25 degrees. And then this one down here, this will be 90, so 1's 90. 27 will also be here because of the symmetry of the kite. So 180 minus 90 is 90. 90 minus 27 gives you 63, and so we know that this will also be 63 because of the symmetry of the kite. Now a little algebra with the kite. This is 90 in here. So if we look at just this triangle here, we can say 90 plus 2x plus 10x minus 6 is 180. And so 12x minus 6 is equal to 90. 12x is 96. And so x is 96 divided by 12, which comes out to, let's see, that's 8. And then, so we don't really need this information here. That didn't help us. And then for this one, we know that this angle here will also be 5x minus 1. And that's a right angle because the kite's the diagonal, perpendicular diagonals. So again, I can say 8x plus 5x minus 1 plus 90 is 180 by using this triangle here. And so that's 13x minus 1 is 191. Or, excuse me, I got a little ahead of myself. 13x minus 1 is equal to 90, so 13x is 91. So x is 91 divided by 13, which is going to be 7.